All right, so let's take a look at another example here. Let's look at these and try to decide if these look like they're theorems or if they look like something that's not a theorem that maybe we would want to try to come up with a counterexample to instead of trying to prove. So what about this? This says something is F or nothing is F. Or, there's something that's F or there is not something that's F. In other words, nothing's F. That's pretty clearly, this is pretty clearly a theorem, okay? It's got this form. It's got that form once again. And so it's something that we could prove without using any quantifier rules. We could prove this exactly the same way as we proved the theorem in the last video, okay? What about this? This says something is F, there is something that's F, or there is something that's not F. That's actually a theorem as well, because when you think about the interpretations of predicate logic, an interpretation always has to have something in it. There has to be at least one thing in the universe of discourse. It's just a stipulation that we work with in this system of logic. And because of that stipulation, it's going to be impossible to build an interpretation where this isn't true. There has to be at least one thing in the universe of discourse. That thing's either F or it's not, right? And, if there's more things in there, that's fine. Those things have to either be F or not as well. And so this is always going to be true. So let's see if we can go ahead and prove this, okay? And the proof is just a slight twist on this proof. So this should look pretty familiar to you. All right, so again, we have to make an assumption. So we're going to assume the opposite of what we have here. Okay. So this starts off the same way, sort of. All right, so we're making an assumption for the purposes of negation elimination. We're trying to get rid of this negation. Okay. And what the thing is, we have to proceed a little bit differently, right? Because we can't just, for example, assume this and then get a negation on there, show that leads to a contradiction and then get a negation on there, because getting this, that's not going to help us to get a contradiction with this like it does when we're trying to prove something that has this form. Because this is not exactly what we have here. If you notice where this negation is, it's inside of the scope of the quantifier, so that changes the way that we have to proceed a little bit. Okay. So let's do this. Let's assume FA, or there is something that, so we're assuming there is something that's F. We'll call it A, and this is going to be an assumption for purposes of negation introduction. Okay, and from here, this proof is pretty easy once you think of how to start it. Because remember, we have this rule of existential quantifier introduction that basically has no restrictions on it, right? It's one of the easiest rules to use. If we have anything, that has any basic sentence like this or atomic sentence, we can put a existential quantifier on it and replace that constant with a bound variable, and we can just do that any time. There's no real restrictions on when it can be done, as long as it's a formula that has a constant to be replaced with a bound variable. Okay. Now this proceeds just like the last proof did. Okay, so just disjunction introduction on line 3. All right. Now we have to reiterate line 1 down into there. All right, so we have our contradiction here, and we can get not FA. On line 6, by negation elimination 2 through 5, negation introduction 2 through 5. All right, so see if you can guess what we're going to do now. Yeah, the rest of this just parallels what we did here. So this is just a slight twist on that classic derivation of P and not P. P are not P. We're going to do existential introduction on line 6. Okay. And now we just proceed just like we did here. Okay. Disjunction introduction on line 7. Reiterate line 1 down there. Okay, and we can go ahead and we have a contradiction. We can go ahead and close this out and conclude line 10 by negation elimination lines 1 through 9.